So when we talk about real numbers, there's real numbers and then there's complex numbers. Now the complex numbers have imaginary parts, and we'll talk about that later. But everything listed on the screen is a real number. But the most common things are, if you were to divide it into categories, there are rational numbers and there are irrational numbers. Now, if you want to know if a number is rational or irrational, it's easier to think of the irrational numbers, and if it's not irrational, then it's rational. So an example of that is pi. Now, the reason pi is not a rational number is because it is a non-repeating, non-terminating decimal, okay? So if I plug in this calculator that I have in my hand, if I plug in pi, let me show you, well, I'll write it down. But if I plug in pi is equal to 3.14159, and they've used computers and they've been working on this for centuries. That decimal will never repeat and never end. It just goes on forever. So that's what we call non-terminating, non-repeating. So every number that you see listed here, if I plug it in a calculator, it's non-terminating, meaning that the decimal never stops. It just keeps going on forever and ever and ever. And then it's non-repeating. So there is no pattern that repeats. That's an irrational number. So all these are irrational. The square root of 2, if you plug that in a calculator, it goes 1.41, and then this never repeats and never terminates. It seems like a randomness to the number, but it never repeats, it never terminates. And so if you do that with all of these numbers, that's what happens. Okay, those are irrational numbers. Everything else is a rational number. Okay, so a rational number means it could be written as a ratio. In other words, you could write it as A over B, but B cannot equal 0. Okay, because then that would not be a number at all. And then within that, we have integers and whole numbers. And those are sometimes like what we would call counting numbers. And some textbooks call those natural numbers. The natural numbers are the counting numbers, sort of, and then there's some discussion about whether 0 is a whole number or not, because really it's not a number, it has no value, but it's a placeholder. But for the most part in high school, integers are counting numbers that are positive or negative. Whole numbers are just the positive integers. The square root of 4 is a counting number because the square root of 4 is 2. But I know that some of my college professors would say technically the principal root of the square root of 4 is positive 2, but you also have negative 2. So technically you could say that the square root of 4, because it could equal negative 2, is an integer and not a whole number. Like it's half of that is true. Like half of it's a whole number. The positive 2 is a whole number and the negative 2 is a whole number. And so those are a big chunk of the SAT if you understand what that means just by being able to identify the numbers, because the numbers have rules that you use for them. That's why it's important to identify them. Okay. And